All right. Let me know if you could hear me. Looks like we got one person there. This is just going to be kind of a test run, see how this goes. The setup here is kind of crazy. Because I use my laptop for Fusion 360 and Photoshop, Premiere, all that kind of stuff. It's a workstation laptop. It's a beast of a laptop with a Xeon processor and Quattro 4000 mobile graphics card. But none of my other computer hardware really can handle it like this thing can. So I got it jammed in here where I was gaming and using the setup that I had before, but just kind of plugged the camera in, got the microphone plugged in. But I wanted to be able to have... So I have a bunch of sketches that I'm going to be working from, and I wanted to be able to access them easily. So I got two mice set up. I should be able to pull them up over here. And we'll just wing it and see how it goes. What's up, Joe? How you doing, buddy? Good, good. I'm glad. How's it sound? Does it sound okay? Hopefully it sounds legit. I was dealing with another thing, too. Don't know where the issue was occurring, but I had to go in the Streamlabs software and delay the microphone by like 230 something milliseconds, because it was like just off enough that when I would do a recording I could see it, because I'm using a Sony a6400 camera for the webcam with one of the Elgato Cam Link things. I tried to use the camera on its own, and I should have... Okay, great, that's awesome. I'm glad, because I've been racking my brain trying to get it all sorted out and make sure it looks and sounds good enough that people will want to hang around and watch. So but yeah, I haven't done a Fusion stream yet, so I'm interested to see how this is going to go. But I got a big Distro-plate order that I'm working on. It's all for the same project, but it's 4 separate Distro-plates. They all link together. And today I think I'm just going to do like the initial, probably just work on the one main one, because that's going to be probably the coolest looking showpiece one. And this project's going to have a lot of design kind of reiterations. We're going to go back and forth and get all the designs. Hey, how's it going? Thanks for joining. We're going to go back and forth and see kind of what ends up working. They got their idea from a YouTube video, and we're going to kind of resemble it as much as possible with its own custom spin. We're going to have cover plates with laser engravings. There's going to be a whole lot going on with it, but I think it was just going to be easier for me to get the base design kind of done with what they were able to send me. It actually works out kind of good, because what they sent was pictures of cardboard mock-ups, and that's usually what I recommend people do if you want to have a distro plate made. I mean, ideally, if you want to save the most amount of money, you're gonna have a 3D model with the specs already in. Ideally, my specs that I send to you, for the channels, the screws to use, everything like that. All the parameters and specifications of a distro plate, O-ring size, all that stuff, so you know you're going to have a distro plate that assembles and doesn't leak and works well. So that's going to save you the most amount of money. Send me the design that's already done, and then I just send you back the parts, and then you assemble it, you test it. It's kind of, you put a lot more responsibility on yourself. You're basically paying for machining, and that's it. The more expensive route, which is going to be the majority of like the computer building market, because not everybody has Fusion 360 and knows how to operate a CNC or even knows how to design. You get into the space of needing to design for CNC machining, and even a lot of engineers run into this problem because they don't account for that. They don't think in their head like, okay, this is how the spindle cuts, this is how you want to run with this material. They're just like, oh, this looks sweet. Look at all these chamfers. Let's break an edge there. And they got chamfers on these ridiculous parts, and you're like, you don't need that. You know, the machinist is like, well, fine, you just added thousands of dollars in chamfers to your part. You know, so thinking for machining is definitely a helpful thing to do. But this is going to be like what most people are going to be doing. They're going to have a ruler for the most part, and they're going to go through their case, and they're going to try to measure it up, mock some things up. And cardboard is the best way to do it. Get a cardboard piece that you can cut accurately and kind of set it in place and stick it up there with double-sided tape or whatever. Then you can kind of put in your computer hardware, your components and everything, and mock everything up like that. You can that way you can at least visualize it, and then right onto your cardboard you can, you know, put in all as best or close to accurate dimensions as possible. So that's what I recommend everybody does without having access to, you know, 3D modeling software, knowing what that kind of stuff is. Or, you know, ideally you would like to have a set of calipers if possible. Like that would be a great first step tool if you're planning on getting custom work done from other people, at least frequently. But calipers are a great, you know, metrology tool to have at your disposal, because you're going to get, you know, accurate to 1,000th of an inch what you need to be measuring. So basically, I don't know how I'm going to be able to show it on stream, but let me see here. I'm going to switch over to the Fusion scene. I'm going to be going back and forth here. And this was an old Distro-plate that I worked on that I just screen grabbed for a thumbnail. But I'm going to pull up the images on this other machine here, on this other monitor, so I can keep them up at all times. Unless I don't want to have to click down from Fusion and go back up and everything. I also wanted to send a post out that I don't know how long I'll go today, because we have about all this week for the materials to arrive. Everything should be here by this weekend or like first thing next week, and I was hoping to start cutting next week. So we're going to be bouncing back and forth with the design stuff this week, so I figured, well, maybe I got pretty busy over the weekend. The spring sale just ended, so I wanted to get all those orders kind of finished up and ready. Most of them were packed up and shipped out today, so I figured maybe I'll do a couple streams this week going through the distro plates and stuff, and then I'll also be doing some gaming streams over on Twitch as well. The link for all that stuff should be in the description. I hope all that stuff came together right, because I haven't streamed to YouTube much. I think I've only done one or two other like live stream things like this to YouTube. But I wanted to post on Instagram and stuff that this was live, because there was a couple people who had said that they wanted to check out the Fusion 360 stuff. And I wanted to gear the shop, or like not the shop, but I wanted to gear like a lot of my media stuff towards the live streaming. That's why I've kind of put money into cameras and like the laptop setup and all that, because I've tried over and over, but I just never find the time to edit videos how I would like them to be edited, and I don't have the funds to pay to have every single video that I post edited. So I'm going to be doing probably a lot more phone videos for YouTube, and then I would also like to try to do just like more live stream stuff. If okay, great. I'm glad to know that works. But just trying to find, and Joe, you probably know, like trying to find time to edit your videos, and then trying to get them the way you want them. And like I'll spend so much time just trying to figure out fine details that it's just like, you know, I should have just picked up my phone, streamed the whole, you know, clip the whole thing in one clip, and those videos do almost as good as the highly edited videos. You know, most people just want to see the content, want to see the parts that are being made, want to see the machines working, want to know different things about the machine, tips and tricks and that kind of stuff. So that's what I'm going to try to do, is focus on streaming stuff and, you know, unedited clips. And then once I have more time, or I'm able to get somebody on board that can help me with that kind of stuff, because things are about to ramp up quite a bit here, actually, over the next, I don't know, few weeks to a month. And my buddy Petey will probably start helping in the shop again, but I really want to get somebody on. Before I actually bring him on board, I want to push myself as far as I can production-wise and get somebody to help me do, like, the marketing stuff. I really need, like, that's who I need to bring on, is somebody to do all that stuff. Making sure, like, posts from the shop go up and videos go up, like, a couple times a week and that kind of stuff. Now, the only thing that kind of sucks is I don't know how to get a link from... I'll get more prepared for this for the next one, but... I wonder if I could just pull it up on YouTube. Alright, hold on one second. There we go. There's the link. Okay. Yeah, video production is just, it's not where my strong suit is. You know, I've figured out, like, the bare minimums of running Premiere, getting your clips in, kind of getting some transitions going. But, like, the video my buddy edited for the Tormach arrival, like, when I saw that, I was like, oh my god, what am I doing? Like, I spend hours editing up my videos to put them together with just some songs and all, like, you know, all the stuff cut out, you know, ums and ands, and trying to cut it down to make it more concise. I spent so much time doing that, and then, you know, in one work day, he's got this, like, masterpiece video with all these great edits, all this different cool stuff in there. I'm like, you know, I can't compete with that. And in my head, when I sit down to edit, that's what I'm, like, aiming for. I'm like, I want it to be like this, and it just, you know, it never gets there. So I'm going to get going on the designs part of this. Maybe I'll do probably, like, I've already wasted about 15 minutes rambling, but I'll probably do about a half hour, get the basics of the first manifold done, and I'll work on some more of it tomorrow morning, and then maybe I'll do another stream of it tomorrow, kind of going through some more of it, because this one's going to have some cool stuff in it, with these cover plates and some laser engraving. One of the distro plates should have, most likely, depending if we can fit it, a central kind of reservoir in it to hold the water. It was originally going to have two exterior reservoirs mounted on it, but I think if we're going to, you know, I recommend it if we're going to do a big, if the distro plate thing is going to be like the centerpiece of the build, it would be nice to have some built-in reservoirs, kind of make it what people want to see. You know, if you invest all that into the distro plates, you might as well not have them covered up by other reservoirs and stuff. So hang on one second. Okay. So I'm going to be working basically from completely rough sketches. We got a handful of dimensions. What I'm thinking right now is I'm just going to get, like, the basic components in. I'm going to get the base of the distro in, start dropping in the fitting ports, and then what I'm going to do is kick it back, get a little bit more of the dimensions, and then bring it into fruition. So I got the main one up. This is going to be like the main, kind of like the main front and center distro that'll be sitting next to the motherboard tray. the first thing I usually do is I'll save the project. Let me get back to the get back to here. He's got this labeled as Distro B, so I'll do that. And the first thing I usually do is create a component. For each body that is going to be a separate part, I make it into its own component. It gives you a lot more control over the part itself. And instead of like, a lot of times when I get a Fusion 360 model from somebody, it is just a ton of bodies and sketches. And that first it just makes things super cluttered, and then you can't... it's difficult to organize, but then one of the most important parts is it makes it really difficult to go back. There's a good like timeline that you want to work towards with it, because if you go back and try to edit something with parametric modeling software, you want to be able to go. What I'm going to be able to do with this is each sketch will have its dimensions and constraints in there. So if I need to go back and change something, say we have a fitting at this XY location, and we need to move it over. I'll be able to just drag that or redimension it, and what it'll do is it'll move the O-ring channel with it, it'll move the screw pattern with it, and everything will go with it. If you have just a ton of bodies and a ton of sketches all over the place, it makes it incredibly difficult to go back and do edits like that. What you end up having to do usually is come back and kill your sketch, redo it from scratch if you need to make a change, and that kind of defeats the entire purpose of parametric modeling software. So I'm going to go ahead and create a new component for this one. I almost always work on the XY plane. You know, the top plate of the distro is the Z axis. And then I hit S, we'll create a sketch here. And, well, get it on the right plane. I'll rename this component Distro B, and I'll make it actually the base. And what I tend to do is, if you're looking at a distro, I make the whole base plate first, and then I start cutting away from it. I found that's the easiest and kind of best way to go about it. Gives you the most control over the components and like things you're doing to it. Alright, so the main outer dimensions of this, and I think we're going to be changing these, so I'm going to kind of keep it within the dimensions we had spoke about. It's supposed to be 17.5 by 19, but my machine only has maximum 18 inches of travel, so I actually was able to squeeze out an extra ½ inch by going into the code and changing it. I think you can over travel them about 3/4 of an inch, but I like to stay a little bit within the machine boundary, just so you're able to get if in case you have to surface the part, you can get your cutter going across the full surface of it without touching down on the edge before it starts going and leaving little swirls there. So on the vertical, I think we're going to try to make it. I'll leave it at 17.5, and then we'll see if that's going to work. If it needs to go out to 18. We'll make it go out to 18, but that'll be like the max of it. And then the width is going to be 7.5. And then we're going to have an area cut out of it, but I think I'll cut that out from the top. Or maybe I could do that in this sketch because it's the main base of it. 8 inches, 16. So we're going to have like a little 45-degree notch that comes in here, and I'll come back and hit those dimensions. So it'll be like a little cutout here. This is where the motherboard's going to sit, so the cables can creep through from behind the distro plate and get into the motherboard. So we'll dimension these angles first. It should be 130. I'm just going to do straight 45s. So that'll be 135 on the outside, and then same with this one, 135. And since this is parallel to this, The inside angle should be the inverse. That should be 135 here and 45 on the insides. Like for example, this sketch is missing a few dimensions too, so I'm just trying to rough out, you know, the main shape, get the fitting locations in, and I'm going to be changing some of those as well because it's drawn up for a dual reservoir setup that has two parallel fittings at the top and the bottom. Assuming that you would fill the loop through the reservoirs and it would feed into the distro and then into the pumps, and then the pumps would funnel it through the rest of the system and then feed back into these channels that would end up coming back into the reservoirs. So I think we're going to try to get rid of the reservoirs and feed everything right from the ones directly in the distro. It should work out. We might have to come up with a different fill port. That might be something we're going to have to look into. The other great thing is we'll be able to just, if we need to add a fill port, we could just pop a fitting right into the model and, you know, make sure everything's all fine-tuned before we get to cutting and everything. So I'm going to start dropping some of these fitting, or no, not yet, I'm sorry. I'm going to trim this. Let's see. I'm going to trim this area here to get the actual shape that we're looking for. And if that is... eight, so if I took an... we'll go. All right. Alright, so it should be looking something like that. That's going to be the base sketch, and that should be good. All the fittings, when I drop in fittings and channels and everything like that, it's all going to be from the top of the base. I'll be doing another sketch on there, so we can go ahead and extrude this. I hit E for extrude, and we're going to pull this whole thing up 0.5. The ideal, what I always would call the ideal setup for a distro combination is a 1/2 inch base plate with a 1/4 inch top plate. That gives you a really rigid base. It gives you long enough depth to put threaded holes in, so you don't crack the distro plate when you're torquing in screws. You can use a little bit longer screws, so you don't have to. You're not just you don't, especially when you're in acrylic, you don't want to be grabbing only like, you know, a 1/16 of an inch of material or an 1/8 inch, because the pressure you need to push down on the O-rings is going to crack all of those holes. So what I'm going to try to do here too is I'm not going to bounce any of these top dimensions off of this cutaway area, because that's probably going to have to get edited. So I don't want any parts of this next sketch dependent on that, because if that changes, I don't want anything else to get changed here. So I'm going to start roughing in the reservoir areas and like how they're going to come in. There should be 2 fittings at the top and some nice wide water channels and then these will feed down to another fitting that'll go into the pumps. And I'll have to figure out if the pumps are going to be directly mounted into the distro, because then the distro plate will need either through holes to, you know, put nuts on the back to mount the D5 pumps, or direct threads to mount the pumps right into the distro plate. Wait a second here. I just like to make sure that it's not even really a big deal right now, but just to make sure everything's aligned. All right, so I'll close that sketch out. So now I'll make a new sketch on top of the All right, sketch number 2 is on top of the base. And when you're doing these sketches, the ideal thing is to make sure that you have your sketches on the component that you're doing. So, wait, why is that not showing up on stream there? That is weird. The browser area here is not showing up. Well, that is really weird. Well, I'll look into this afterwards and see. I'm just kind of winging it with this one so far, being the first Fusion 360 stream. So, basically, once you have your base sketch done, you extrude your body from it. You want to make sure that the actual component you're working under is selected, and that's kind of what helps keep you grouped together, keeps everything grouped in the same spot. You don't want sketches from like sometimes you will have it where if you have a new component that comes off of this one, I always try to make a new component though when doing the distros every time I need a new body. So if I'm going to make the cover plate, I'll make a new component, highlight that one, start a sketch, and then I'll use the base plate as the sketch plane to make the top cover. So we'll get this new sketch started here. So select that, new sketch, and then this is where I'm going to start dropping in the fittings. What I actually like to do for whenever I'm working with something that, well, this is going to be the channel, so it's not as critical, but like if I'm going to be doing fitting holes, what I like to do is I'll drop a point in the sketch instead of drawing a circle. Now it doesn't really matter. A circle is going to give you the point too, so I guess I could go with that. That might actually be, it's probably something that doesn't really matter too much. So you want to make sure your threaded hole for that is going to be 11.2 millimeters or 11.7 millimeters. I know that my drill bit is a 30 seconds, and that's going to be like the pilot hole for a BSPP G 1 1/4 pipe thread, and that is what all the water cooling fittings are. So we're going to have one coming in at the top here. I'm just going to Control C, Control V, and copy another one. So this is going to be for each kind of water channel area, and hit OK. I'm going to make another one, Control V, and this is going to be the one coming out for the pump. Hit OK. Oop, not there. Oh, that's really weird that it's not showing the whole browser tab here. I'll have to figure out why that does that. But now I still got it copied, so I can drop another one here. Go down to that one and go over. And these sketch components can all get moved around a little bit. Hit OK on the copy. And we got two more. Another down there. Just drag that one like that. Another there. Okay. I'm going to check out this other picture too, because there's some mounting holes that are going to be in this. Okay. And I have to confirm something too, because it looks like the pumps might actually, I don't think they're embedded. I think they're just mounted with like a pump top, so we'll have to figure that part out too. But I need to add a couple more. Okay. Alright, and then there's going to be a couple other little mounting holes, but I think I'm going to wait till I have the top piece done, because those holes will probably go all the way through. So it'll be easier to do that in the top sketch for the a top sketch on top of the cover plate. So once I have like where the fittings are going to be located, I'll start connecting the dots basically. Yeah, I think those pumps are on pump tops, and it's coming in through the top of the pump top, out the side, and then into the bottom distro plate, channels around into the radiator, up to the second tier distro plate. So okay, starting to make a little bit more sense here. So I'm not going to put any kind of dimensions onto this fitting here and this fitting here. I'm just going to start building out the design for them, and then I can pin them down once we confirm exactly where they're going to be located at. So what I'll usually do is, you need a decent amount of space around the fitting, because when you're coming in with your fitting through the top cover plate, you don't want the threads to be smashing into like the inside of your channel. Like if you try to make your channel here, you know, where we have these holes, they're at the size of the ID or the inside thread cut. So the threads are going to be cutting into those, and the outside of the threads for the pipe or the fitting screws, threads, they're going to be bigger than that. So you don't want to drive that into your channel. So I'll usually make a slot, and then we'll open that up, or we'll offset this. Actually, no. We'll make another circle outside of it, because since these are going to be a unique design, we won't be doing an actual like slotted path. What was it? I'm gonna go 15. Yeah. Hold on one second. I'm gonna actually grab a couple fittings. I got some sitting here. So we'll go 0.6. Just a little bit bigger than what I was doing here. But I want to keep everything in standard, because O-ring stock is all done in imperial sizes. The material itself is all imperial, so it's just easier to make it rounded that way. We'll do the same thing here. 0.6. Now, since these are going to be opened up a little bit, we have some room to play around here. And kind of bring them out, and I want to watch the edge here so I have room to... You got your little space between the channel and your O-ring, which I usually do about 50 thousandths, and then the O-ring channel is going to be 3/32. I'm going to cut them usually with the 3/32 ball nose or bull nose end mill. Having the rounded edges on the inside of the channel gets you more surface area compression. Obviously, if you use soft enough O-ring, it should compress into there anyway. But if you have sharp edges on there, sometimes it'll compress and kind of cut little pieces off your O-ring stock. I just like the rounded channels. So if you go with 3/32 cutter, ball, I usually use a ball nose, and you go about 80 thousandths deep, 85 thousandths deep. If you have your plate nice and flat, and then you use 3/32 O-ring stock, it basically it clicks right in place all the way around, so you're not worried about your O-rings. I used to do them a little bit bigger, but then you'd have to be sitting there kind of like hoping they don't pop out of the thing before you get the cover plate on and all that. It's nice when they just click into place, and then you can fit it in all the way around, and it just stays there. And it also works well when the two ends of the O-rings are coming to meet up. You don't have to use super glue or nothing like that. I use the O-ring cord stock that I use is a high temperature soft silicone cord stock. It's like 55 durometer. It's worked. I feel like it works a lot better than the regular like oil O-ring stock, the Bunna N O-ring cord stock, and like the Virtol or whatever it's called. There's a bunch of different types on McMaster. I've probably bought 15 or 20 of them just to play around and see how they compress and see how they perform. And this silicone, I want to make sure that's a vertical. The silicone cord stock, anything that's really soft, the softer it is, the better, because there's a couple times where they've sent me the wrong cord stock, and I think on like the first one or two distros that I did, I was looking for, it said that it was soft, but it was still like 60 something durometer, and the force you need, it basically was too hard for acrylic, because the force you needed to compress the O-ring and get a seal was too hard, and it would easily crack the acrylic, or you would think it's compressed but it's really not, and it was super prone to leak. So if you use the softer silicone cord stock, it's almost guaranteed not to leak if you get a nice good compression. You don't have to worry about over torquing your screws and cracking out the threads. I think I have quite a few manifolds and reservoirs that are over 5 years old, going out, running day in day out, going strong. No leaks, nothing. So, and I know a couple people have even taken them apart for maintenance, took the O-rings out, cleaned them, put them back in, and it's still working like brand new. So I'm right now just roughing in this kind of design here. Come on, give me that pivot. There we go. I think I might copy that on the other side, but a lot of this is open to interpretation right now. We're just getting it dialed in. Most thing I'm gonna have to worry about is clearance in this area, making sure that I can get the mounting screw in there, and that's not going to conflict with it, and getting the O-ring screws, the O-ring channel, O-ring screws, all that stuff. I think I'm going to kind of mimic that on this side too. And this project, like I mentioned before, is a lot more looser on the design aspect, and like we're gonna kind of bounce back and forth and see how it looks, make adjustments, and dial it in. Be working on that throughout this week. Oh, these are gonna be like larger channels. I might adjust these lines. I want them to be symmetrical. What I actually might do to make them symmetrical is dial in one and then copy the whole sketch segment over to the other side so I know they're exactly the same. That's usually the best way. If you got two kind of sketch objects that you want to be the same, just get one dialed in. You could either mirror it, which I won't have to do that here because I'm going to dimension out the distances, or you can just copy the whole sketch or whatever. And if I'm stretched or squeezed on that side, I can bring it in that way. In that case, I probably will mirror it. If the edge, yeah, if it's not going to be a symmetrical thing, I'm going to probably mirror it so it's like inverted the opposite direction. Go ahead and delete that. Make a sample mirror line. That line is just going to get deleted in a second once I grab this and go up here to mirror. It has all that selected. Then you click here. Man, I don't know why it is not showing any of these. Pop-up bubbles. That's not very helpful. At least it's not showing it on my Streamlabs. I can't tell if there's anybody in the chat, or let me know. I'll have to take a look at this once the video posts. But there will pop. There goes the stream, or the mirror. I'm sorry. So now it will be the identical look. And I believe anything that changes over here is going to change over there. So now that they're mirrored, all I have to do is kind of dial in how I want it to look over here, and it'll be mimicked over there. But you know what? I'm gonna because I want to cut away from this, I might mirror it. Yeah. I'm going to mirror it once I have it locked out and ready to extrude. Then I'm going to mirror it and then extrude both of them so they're basically dialed in already. Because I'm going to have to click away some, trim off some areas here. I'm going to trim off this area inside here so so the outside of this is basically going to be a pocket. And I'm going to get some fillets on the corners so they're a little more rounded off. I was really hoping to do about 45 minutes to an hour, but I'll stretch this out to an hour, and I'll do a little bit more off stream. But I'm gonna come back. I think I'm gonna keep going with this and do another stream on this. All the orders are packed up, so I'll probably do it a little bit earlier tomorrow. Actually, we'll pop back and we'll get some information on the. Kind of want to make these a little bit bigger. Alright, now we got a border. And the other great thing is if I want to change the shape of this, every move I'm going to make here will change with what I'm going to do. So once I select the line, I'm going to hit O. And right now the offset that it's going to do is on the inside, so you want to switch it to make sure it's going on the outside of your line. So it's going to end up being negative the way this sketch segment's made. So I'll go 0.050. That's going to get, that right there is going to be the gap between the channel and the O-ring channel. And then now we're going to gap out the O-ring channel, so we're going to go negative 0.050 minus I don't know the actual breakdown. We'll go 3/32. Good enough. So then we'll do one more. I want to have a little bit of space between the O-ring channel and the screws that you're putting around. Now, a lot of these parameters are able to be edited. You know, sometimes I've had a couple manifolds where I'm working with really tight spaces, and I had to take like the outside of the fitting and trim it down to like I think it was only like a 3/8 or a 1/4 inch channel, so it was really tight along the one edge of it, and then I was able to open it back up to a larger chamber. Now, if you do stuff like that, you're going to end up with water flow restriction and that kind of stuff. But it's possible, and I'm trying to get away with using most of my common provably solid specifications that I've come to basically have ingrained in my head over the last 8 years of making these things. Now, I haven't made one live on stream like this before, so I'm trying to figure it out as I go here, and like narrated the whole process, you know, but it's all good. So I want to probably have almost a 1/4 inch space. So we'll go offset minus 0.144 minus 0.225. And then this line I'm going to make a construction line because it doesn't have a purpose, it's not being extruded, none of that. And basically, if it's a construction line, when you go to extrude any of the surfaces, it won't pick up on it, and you won't have to click extra segments to be extruded. So it's just there for reference, dimensions, that kind of stuff. What I will use this for, though, is doing a hole pattern on a segment. So they let you pattern out holes in different components. So what I do is I get the first hole in, I select it, and then I'll run a pattern on a path. And it basically lets you take the hole that you've put in. So I'm doing 632s for most of these. So it'll let you put in that, and then you can pattern that hole along this sketch segment that I just made. So then you can adjust the spacing. It'll let me put a hole or a circle or whatever you want to do to reference your all your hole pattern. It'll let you pattern that every inch. You can say you want 20 holes around the whole thing, and it'll evenly space it, and that's basically where all your screws will go. So all the screw threads are going to be cut on the mill. All the fitting holes are going to be cut on the mill. Basically everything is going to be machined in this one, so it gets you the most reliable results. Like I've tapped many distro plates by hand because my old machine wasn't quite accurate enough to do thread milling. There was too much backlash. It would have been all over the place. So a lot of the older ones I did were all drilled on the machine, but then I would come back with cutting fluid and a drill and just tap them all myself. But you get such a nice, better looking thread when you have everything thread milled on the machine. Now with the machine that I have now, I could even rigid tap it, but the thread mill puts it puts such a nice finish on your threads when you're cutting acrylic. So that's what I'm going to be going with here. So here we go. I'm going to go with a now I have the roughed out pocket there. I'm going to bring down the segment again. And now I'm going to select all this stuff. Oh, come on. And now I'm going to mirror that on this line again. Oops. That's what I want to do. The segment you want to... See, it's not popping up there. It's really frustrating. I'm going to have to figure that out for the next one. And we'll definitely do another one of these streams this week. I'm going to have a lot of distros coming up. I already have 2 more on deck other than this project. We're still in the whole quote phase and everything. So that hopefully they'll be coming out soon. And if whatever client is cool with me doing that, I'm going to try to get a stream for it. So we'll mirror it on that line. And the cool thing about this parametric stuff is now anything I edit, it just makes it so much easier. You know, I've gotten so many models where you guys can't see that either, but there is I don't even know if I could drag it to you. Why is that not showing up there? Maybe it's something with Fusion 360. I don't really know. I'll have to look into this here. But the timeline that it'll basically clock out a timeline for you. Every move you've made, basically, every extrusion you've done, every sketch you've dropped, every hole you've made, all that stuff will be going in a timeline. And then you can kind of rearrange that too. It lets you move someone around. Some of them are dependent on each other, so you're constrained with you can't move them around too much. But some of them you can move around, so sometimes a feature is dependent on another feature, but sometimes other ones aren't. So you can take a feature and move it to the beginning of the timeline so it's not affected by the other one. Say you added a hole over here because of this feature. You saw the feature and you wanted to add something, but it's not dependent on it. You can actually take that hole and move it back to the beginning. So it'll help a lot when you're trying to like remove a feature to do some machining, because sometimes you need to patch in different stuff to get the right tool paths dialed in and stuff. I'm also going to do a stream for how I program up some of these things. I don't know if I'll do the first ones because I'm going to be getting used to the new programming method. I've been not all. I've done a handful on the Tormox, but most of my previous machining experience has been with a high-speed spindle and a router. Now I only have 10,000 RPMs. Usually not ideal for plastic, but it's going to be all tooled up for acrylic cutter. So once I kind of have my proven recipes dialed in, then I'll do a stream going through with, I think it'd be a good idea to go through a stream of like what the difference was, how it is compared to using a 20,000 RPM spindle versus 10,000, the difference between a single flute and I'll probably be going with a 2 flute end mill. 3 flute just screams and squeals when you try to cut plastic for some reason. I don't know what it is, but probably not pushing it hard enough. But like then you come to the, with the speeds and feeds parameters, it's like, okay, well, is this held down hard enough to really push it with 3 flutes, or am I going to rip the piece off of the double-sided tape off the spoil board? So there's a lot of different things you want to take into consideration there. So I think getting some specific, Harvey Tool has some specific for acrylic and plastics 2 flute cutters. I'm going to go with a couple of those. I'm also going with a couple Datron tools. I'm going to be getting their 2 flute polishing bit. I think the Tormox are rigid enough that we can bring back to optical clarity with their specialty one. And also going to be getting their G 1/4 thread mill. Those are all on the way. So this should be a fun project, and I also want to get some video footage for the YouTube channel for the actual machining of the distro plates and stuff, and all the future ones coming up, because basically I'm open for custom orders now. The hiatus is done, but I really want to narrow that into something that I can build a workflow off of, and that's always been water manifolds and distro plates and stuff. So now I have the 2 channels kind of marked out there. I'm going to go ahead. This one also is, these center lines are also, oh, that's not what I wanted to do. These are also construction. They're just there for reference to keep those 2 kind of fitting holes. I did the same thing again. Attached to each other. And even this line is a construction line. So what I like to do is, because there could potentially, I don't think these channels will, these are all going to be from the top, so I'll drop it down. But the reason I go with 1/2 inch thick material for the base is because I like to bring down all the channels and the cutouts and everything down to, well, if there's not going to be a fitting on the back, I can bring it down 3/8 and you can have a nice amount of liquid in there. But a lot of times, like if there's going to be a fitting that you need to have come from the back side of the reservoir or manifold or whatever, you want to have some meat there for the fitting. I've done a couple like squeaking by with like 3/16, but you also have to look out so that the threads on the fitting aren't hitting into your channels, they aren't bottoming out on the cover plate or anything like that, or running into any issues. You also want to make sure that you can see how these threads aren't all the way down to the O-ring. You want to make sure that these don't like pop. You don't want to have only like an 1/8 inch of material and have these threads pop all the way through and then have it start spinning in space and not actually be locked on nice and tight. So those are some things you want to take into consideration. So like the most simple way to go is with a 1/2 inch base, 1/4 inch top plate. You can, if you need a fitting on the back, you only got to go down a 1/4 inch. 1/4 inch is a perfect amount of meat to get a nice torqued on fitting and not have to worry about anything. So we'll drop these 2 channels down and the little fitting areas. We'll do an extrude. That guy, that guy, that guy, that guy, that guy. And we'll go minus 0.25. And boom. There's our 2 water channels. So sometimes, and I can't see it, and this is frustrating the hell out of me, when you do an extrude working from the sketch, it'll turn the sketch off once it's done. So just come back over and there's a little eyeball next to the sketch over here. Flick it back on. And now we're going to come over and we're going to extrude our O-ring channels. So hit E, and we'll grab this other one. And these, I think the last one I did was 75 thousandths. Now it depends like how precise you want to get, and if you are worried or care about a slight gap between your top panel and your bottom panel. If you want reliability, leaving a little bit of gap is probably the best way to go. So I think I'm going to go with like 80 thou. That the O-ring stock, the decimal dimension of it I think is 0.103. So it's a little bit thicker than 3/32. It's marketed and sold as 3/32, but like the actual spec is a little bit oversized. So that gives me about 20 thousandths of compression, and I'll think over on that, but that's what I'm going to do for now. And just for the sake of kind of wrapping up this stream and the generic basic of getting your first couple channels in, your base plate and stuff. And I think I'm going to keep going with this. I think this is pretty cool, and I'm at least able to go long form and really explain this stuff instead of trying to cut it up. So if you're really looking into from the bare bones starting and sketching in your own stuff, because you don't need this exact sketch either. I mean, as long as you follow the little bit that I said before and you kind of get in your parameters there and your offsets from your channel, you can sketch in your own circle, put an offset on it, put another offset on it, and then put another one on there, and you get your 3 kind of setups, your channel spacing, your O-ring channel, and then your threaded hole tool path. And then once you have that, you can play around and do different shapes, do whatever you want. At least it'll give you a little bit of something to practice getting in those shapes, learning how to make your component. So that's basically that. And then what I'll do really quick before I wrap this one up is pop on the pattern on a path and show you guys what I'm talking about. So right here, I wonder if I could actually just make it work right off this corner thing. At one point there was some bugs with this whole pattern on a path thing, so I'm going to add a hole. No, I need to drop a point at least. So we'll go back and edit the sketch, and we'll put a point in on, and actually it should mirror it to the other one too, so I only have to do this once, maybe not. We'll see here. Now, at one point, pattern on a path was bugging out, and there was tons of tickets put into Fusion 360. If you're using other software, all of them have this same kind of feature, like if you use an Inventor or SolidWorks. My ideal setup is if I can get to the point where things are really growing and expanding, I would love to have SolidWorks and Mastercam, but you're never going to hear me complain too much about Fusion 360 without this software for the price. For most of my career with it has been free. Only have I been paying for it for the last couple years, so I really can't complain. I mean, it's allowed me to scale way more. I would have had to use some bootleg version, which is illegal if you're a business. I do not recommend doing that. If you're some kind of hobbyist, I don't condone it, but you can do what you want. You don't have to worry about someone narking on you. There's hotlines for people using cracked software. So if someone finds out you're a business and you're using it, they have tip lines. They'll pay you for calling and narking on people. So I wanted to stray away from that. And for the Fusion 360, when I first started with it, was at that free scale where you basically had access to the whole program except for a couple specialty things. And even at that, it's only $60 a month. It pays for itself when you're making parts. This Manifold project paid for it without a problem. Obviously. So I don't complain very much. It would be nice if they worked out a couple of the little bugs, but we'll see how this works here. So I put down my sketch point, and then you can do it in a sketch. You can also do it with a actual, what is it called here? With an actual, component of the model. You could do it with a hole, you could do it with a boss, you could do it with an actual solid body. I could even do it with the O-ring channel itself. I could take that extruded thing and pattern that all around. So you can do it with quite a bit of things. It's a really powerful feature, and it fills in, because when I first started making manifolds, I would drop in a freaking hole. Well, a lot of times what I would do is cut the gaps. Like, okay, if it's from here to here, there's a point to point, I put one in the middle, and then I put one in the middle of those ones, and another one in the middle, and just kind of symmetrically close it in until I had my ideal spacing. Depending on the screws you're using and the layout of everything, I have different parameters for the spacing. Some of the first ones I did had a lot of screws in it just to make sure. That was when I was dealing with the really hard O-ring stock. Ideally, you could probably go every 2 inches with a screw, and you should have... You can kind of tell when you're looking at it. 1.5 inches, 2 inches, and you're pretty safe if you're using some nice soft silicone stock. So I'm going to do pattern on a path here. So we'll take this, not an object. Oh, I wasn't in the sketch. Or yeah, I was. Hold on. That was the other pattern on a path. So I selected that. Create. I had actually... Oh, where is it? Are they not letting... It's not in sketches anymore? Okay, so... Yeah, so it looks like they took out the sketch version. So what I'm going to... I'll just wrap this up with showing you really quick. I'm going to add my first screw hole here. I'm going to select a threaded hole. I put them in modeled because I programmed through the modeled thread. because it gives you the thread offset built in. So it gives you the size of the hole you need for the thread ID, and then the thread OD is all modeled in there, and you can select each one of those for your thread milling tool. You can get your parameters out of that for your thread milling toolpath. Basically, you select the outer one, use your thread milling tools, single point, and then what I'll do is I'll leave stock to leave, like a few thousandths, just so I'm barely kissing it, and then I'll walk it in to get the perfect thread, the perfect fitting thread. I have parameters already saved to be copy pasted for pretty much every thread size, but I actually kind of want to walk you guys through that when I go, and I'll start from scratch and actually program in there and show you that when I do the programming stream. Let's see here. Threaded, straight up, we'll do a flat bottom hole. We're only going to go 0.3, let's see here. We'll just go 0.375. That should be plenty. And we're going to run a 632. No offsets. Okay. So now you can go down here, which you won't be able to see. But down in the timeline, you can select your hole, and then you can select the pattern on the path. It uses the hole that you selected. You click select, click your path, and let's see here. It's set up for extent, but we'll go space. No, we'll go spacing, and it'll let you start dragging out your holes. So we're at 4 inches, we'll go 2 inches, and then now from here you can just start adding, clicking and adding holes, and I'll get you a close up here. This is 7, 8, 9, 10, 11. So basically you just keep adding holes, and it all the way around your path, and that's the best way to do it, quickest way to do it, instead of going up and adding basically, if you didn't do that, you would go into your sketch, you would add a point everywhere you wanted a hole all the way around, and then you'd have to go and individually click all the holes all the way around. This gives you a more uniform, easy to control, easy to predict 14. Now that last one's not going to have the exact spacing, but I'll try to align it usually as best I can. Keep it kind of symmetrical. I might even work it down a little bit, because a lot of times I'll like to get a fitting or a screw like in some of these internal corners and pinch points. I like to have them in there. But you could even, once you have pattern on a path done, if you see like some areas where like it's going around that curve and the screws are like outside of it really far, you can jump back in. You can just come back in afterwards and add a second hole that's not dealing with the parameters of this patterned hole. But all right, I think that's good. You hit OK. Now you have a patterned set of holes all the way along it. So rinse and repeat on the other side. So it's not looking like, well, obviously, because the mirror will change everything you did before the mirror. It will not mirror things you add to it afterwards. It will. So like you got all your lines and everything mirrored. When you change those around, it'll be symmetrical on both sides. When you want to come back and add points like I tried to do before, it's not going to add those. You'll have to do another mirror for that. But with this, I won't have to do that. I'll add a point in the same spot, do the same exact pattern, and it'll come out the same way. So, well, this is already going on for a little over an hour. I'm going to wrap this one up, and I think I'll be back maybe tomorrow or maybe the next day, and I'm going to be doing a lot of design work tomorrow anyway, so I'll probably do quite a bit of it off stream, and then I'll pop back in and kind of go over a little bit of stuff with you, and then anybody that's watched this or has any questions, they can hit me up, and yeah. And then I definitely want to have a stream probably next week where I start, or maybe I could even do it later this week once all the designs are done, and we can go through like programming, thread milling, channels, pockets, all that kind of stuff. And I'll probably dial one in first, which, yeah, that sounds reasonable. I'll dial one in first, and then I'll go through and I'll show you what I did and on to the next one. So I think I'll wrap that one up here. We got our channels in. We got our pattern on the path. So that's basically, that right there, in very simple terms, is a finished layout for your base plate. Not in the design that I'm going to be doing, but that is what you need to know to make your, just a basic reservoir right there. That's basically just a plain reservoir layout. With the continued streams, we'll get into the more connecting the channels together and all that kind of stuff, and then finishing the top plate, because it's really easy from here. We're going to make a new component, bring it up, and maybe that's what I'll do. Maybe I'll work on the other ones, and then we'll come back to this model. I'll get some more details on it. We'll come back to this model, finish the cover plate, and basically finish this one up, because there's also going to be a second cover plate, and I think that would be a cool one to... I'm not going to be using Fusion for the DXF file that I need. I'm going to be using Illustrator, but I'm going to bring in, I could probably even stream that, how I take a image, bring it into Illustrator, sketch it, and get a DXF file, and then I can bring that DXF file over into Fusion 360, line it up on my panel so you can do a render or whatever you need to do, and then you can export that DXF, get on your laser, do whatever you need to do. So let's see here. I don't think that turned out too bad for just kind of, there we go, for just kind of winging it. And I wanted to just get on stream. I haven't done a video on YouTube in a while, so I guess that's all right. All right, so that'll be it for this one. Tomorrow we'll wrap up the cover. Yeah, I'll hop on tomorrow. We'll do the cover plate, and then later in the week we'll do a programming one, and I think that'll be cool. I'm also going to be doing more YouTube videos, filming with the phone, of like just machine operations and stuff like that for doing the manifolds and everything. Other than that, down in the description, we got one for the Twitch channel. I'm going to be streaming some gaming. I'm going to hop over there now and wrap up my day today. I got most of my work done that I needed to get done. And getting into these designs now is the next step and next on my agenda, so I'm going to be working on that for the next few days. World of Warcraft Dragonflight is coming out. That's the game that I am modding computers because of that game. I was raiding in the fourth expansion, the Mists of Pandaria one, and I upgraded my computer. I'd already had pretty good hardware. I think I had the best processor that was available at the time, or one of them, like the 3930 6-core, and I had a 780 GTX, and I needed to water cool everything because I wanted to try to overclock because I knew I needed more processor power. Water cooled the first case, cut it all apart, painted it, got into it through YouTube videos, and basically put down the gaming and everything just to zero in on modding, and then modding rolled into taking custom orders and launching products, and I really needed something to kind of break from the grind of everything day in, day out. So I wanted to jump back into WoW. Perfect timing with the new expansion coming. I wanted to do a bunch of cool crossover stuff with Twitch. I'm going to be doing giveaways. I just gave away, actually. Congrats to Derek. He won this Atlas GPU support, anodized black. I'm going to be doing more of those. I think this weekend, this Saturday, I'm going to do another stream, and I think we'll give away some contour combs. It's really cool. Twitch will let me do a built-in giveaway right there. All you got to do is come to the Twitch channel, toss me a follow, and then do like exclamation point raffle or whatever I set up the command for, and it'll give you an entry into it. And then at the end of the stream, I'll run the raffle. Last time I set it for an hour, but this next one I'm going to do just like the duration of my stream. So anybody stopping by can jump in, and then I'll announce the winner once it's done. I'll post it like on my social medias. I'll actually fill that into the thing. So like I'll either post the winner on Twitter or something like that. Probably Twitter is going to be the easiest. I might copy it over to Facebook and Instagram too. But we'll do a contour comb giveaway, and I think while I'm trying to build up this Twitch channel, we'll do like some kind of giveaway each week for this first month, and then maybe every other week for the next month, and then we'll do like a monthly giveaway from there. So we'll build some hype and get it going to get started. But I'm definitely going to do a lot more streaming, like 3D model stuff to YouTube directly. I tried to do a crossover stream to all of them, and I ran into all kinds of bugs with the multi-stream setup. So I'm going to try to keep the gaming on Twitch and maybe cross that over to Facebook a little bit, and then I might take the 3D modeling and keep that on YouTube and cross that over to Facebook a little bit, but we'll see how it goes. I really want to build up, the followings on the YouTube and Twitch channel, so I might try to keep those independent. I don't know yet. Facebook's a good buffer because I've built that up the most, so it could help, but that's here nor there. So do me a favor, head over to Twitch if you like gaming, you want to see some WoW playing. I'm about to hit level 60 in the new expansion. We'll get all geared up. I'm also going to do some cool WoW giveaway stuff once the expansion comes. I've got a cool idea for some Horde and Alliance LED signs I'm going to make on the laser, and I might give away one of each, and then I'll have some up for sale. I'll either put them on my website or Etsy. Just kind of to go along with the expansion. I'm going to try to set aside some time to have like a crazy streamathon once the expansion's released and try to race to hit the new max level. I don't know what the level cap's going to be, but anyway, before I keep rambling for another half hour, we'll wrap that up here. We'll come back. We'll get the other final little 2 channels in, and then we'll get the cover plate, and then this manifold here will be done. So, it takes a little longer than obviously if I'm just sitting here clicking through it and just doing it, but when I'm narrating it, it's going to take longer. But if anybody has any questions, drop them in the comments. I built a new contact form, link tree type thing, it's in the description, so that if you ever need to contact, you go there, it'll give you email contact, and then it has all the social medias and the email list. So if you're not in the email list, go ahead and sign up there too. But yeah, that's it, guys. Thanks for watching. Thanks for bearing with me while I'm doing the first one here. And the more I just got to do it. Once the more of these go on, it's going to be a lot smoother, and I know what to plan for and prepare for. So thanks for watching. We'll see you guys in the next one. Take it easy. Let's close this out.